Okay, thank you very much, and thank you for sticking around to the end of the conference. I know everybody's rushing to get home, but I'm here to talk to you a little bit about some climate-friendly farming that we're doing. Hmm? Oh, there we go. Oh, too many. Okay, so this is my wife, Alison, our three little boys. We farm at Woodmount, Saskatchewan, which is in the very south central part of the province. We're kind of high and dry. We're at about 3,000 feet elevation, and we're in the average 12 to 14 inches of rainfall in a year. The last few years have been anything but average. And today I'm going to talk about two very different topics under climate-friendly farming. We recently built an 8,000 square foot farm shop that I'm going to talk about a lot of the energy stuff we did on that. And then we're going to talk about some of the farming practices that we do that can fall into the category of climate-friendly practices. So when we designed the shop, like I said, it's a 8,000 square foot shop, and it's something I'm only ever going to do once. And this is going to be a legacy project for me. This is going to last longer than I am. So the decisions that we're making today are going to affect the rest of our farming career. So a bit of investment up front is going to pay off beyond our lifetimes. So we took a three-step process. The first was energy conservation, that we're trying to design the building to be as energy efficient as possible, that it's going to keep as much heat in the wintertime as possible. And we did that with many different things. That before we poured the floor, we put down insulation underneath the cement. It's about 3/4 inch of foam that's foil backed. I talked to the cement contractor about going thicker. I think it's about an R8 or an R10. And that was as thick as he recommended. But it creates a thermal break between the cement and the ground so that we're not just pouring energy down into the ground. Next, we went with spray foam insulation, which it's got good R value for the thickness, so we can get more R value in the walls and the roof especially. I think we went 30 on the walls, 40 on the ceiling. And one of the great things about spray foam is it is self-skinning, and it creates its own vapor barrier. So we've eliminated all of the convection heat transfer through the walls and the roof. We're still fighting conduction, which that's what the job of insulation is to reduce that conduction. And we're also affected by radiation transfer as well, which I'll circle back to in a second. And the shop doors, that is kind of a necessary evil. We went with as thick and as insulated of doors as we can. R16 was the maximum practical that we could find. One downfall when we picked the orientation, we put the big doors on the east side, which were not protected from the wind. And any little crack with a hard east wind, we'll get wind whistling in through those little cracks. So that's one mistake that I made on that. So now that we've created as efficient of a shell as we can, we're going to collect as much free energy as possible. So we're going to collect all the passive heating that's available. This is the south side of the shop. We put the broad side to the south. We put windows up high, and we're collecting sunlight. In the wintertime, it's coming right in through those windows. We keep the thermostat in the shop at 13 degrees all winter. And during the day, we can typically gain at least 2 degrees on even a cold but sunny day. We'll easily be 15 degrees inside the shop. And it's hard to see from these pictures. Well, you can see in these pictures, but the roof is the same dark gray as the trim color. So we're gaining that solar radiation for the sun. We're heating up the roof, and we're not losing any heat through the roof from the inside out. So now that we've collected all the free heat, we're going to make whatever heat we need as efficiently as possible. As I mentioned earlier, we put in-floor heating loops in the floor. So we're running glycol all through the floor to warm it up. Now we just need to find a way to warm up that glycol to heat the cement. So we went with solar panels. Now, I really was hoping to have pictures of the final project here, but we've overrun our schedule by a lot. But we've got 16 panels on the south wall, And each of these will have an evacuated glass tube. Each of the panels will have 30 evacuated glass tubes that have a copper rod in it. And that copper rod will heat up in the sun. It transfers all the heat up into, there we go, into these headers. These headers are piped into the shop, and they transfer heat into a 1,000-gallon holding tank over here. That comes in on these insulated lines. I took a picture of all the coils before it went in the tank. The heat from the glycol goes through the stainless steel loops that come from the panels. That tank, when it's at full capacity, will be at 180 Fahrenheit. So we've got a lot of heat mass in that tank. When the floor needs heat, when the thermostat calls for heat, we'll be circulating glycol through the copper lines and out through a more complicated system and through the floor. So this is the rest of the system. This is all it is this is a glycol tank here. There's no heater in this tank. When the thermostat calls for heat, these pumps turn on and it circulates glycol from this tank through these down into the floor and then back up and into this tank. When this tank cools down and calls for heat, it circulates with, this is our backup heater, and this now is plumbed in to that hot water holding tank. So it'll circulate with that hot water holding tank, keeping this warm. And when that cools off, either overnight or on cloudy days, this pump and this valve will shut off, isolating the tank, and the backup heater will keep this tank warm without heating up our big storage tank. Now, as I'm sure everybody has noticed, that's right here. That's not a gas line coming into the backup heater. We don't have natural gas where we're at. We can't make propane. We can't make heating fuel. Well, we could get into biodiesel, but that's down the road. That's a whole nother discussion. We went with an electric boiler. We can make electricity. And our plan is, once we get the system up and running, we're going to run for probably about 2 years and then set up a photovoltaic an array that will either net zero or do a microgeneration project, depending on what programs are available. When I planned all of this, our province, like the province of Saskatchewan, had a 20% grant for a net zero system, which now that we're down the road with this project, that program's been cut. So now it's 100% out of pocket. So we'll see what shape this takes in a year or two. So that kind of wraps up the shop project. I just want to spend a few minutes talking about some of the things we're doing on the farm that is contributing to climate-friendly practices. So for a couple years now, I've been tracking all of our fuel use. We log the fuel that each equipment uses, what work it's been done, and you would imagine that there's some equipment that does the same work as an equivalent machine, but one's more fuel efficient than another, and you can tease that information out. And when you're not running two machines in the same field at the same time, you can pick, if you want, you can pick the one that's more efficient and run that. Information that I found interesting that I did not expect is when you're running two identical machines with two different operators, there was a difference in fuel use per acre. The person that pushes the combine hard and full and pushes it to its limit all day is using a lot more fuel per acre than the person that's kind of taking it easy and not pushing it so hard. So I found that interesting too. In about 2005, 2006, about 15 years ago, Saskatchewan had a farm energy evaluation program. We didn't take part in that project, but we used that framework to do an evaluation on our farm. And what the program does is it takes all of your energy inputs, converts it into equivalent liters of diesel fuel, and it divides it out by the tons produced. So for example, on conventional farms, they take every ton of fertilizer you use is an equivalent liter of energy of so much diesel, and then that gets factored into the equation. So on our farm, almost all of our energy use is diesel fuel, so that was a very easy conversion. But we came in at about 25 to 30 equivalent liters of diesel per ton produced. And this is a very fluid number, because if you're producing a low volume, high value product, something, for example, like flax, you're going to have a higher ELDT than if you're growing something like oats, which is a high yielding, high volume, even though it's a lower value. So you can manipulate your own farm numbers very quickly and easily by the crops you grow and the fuel you use. But what I found interesting is when we compared that against the Saskatchewan average from 15 years ago, we're at about 1/3 of the energy used to produce a ton of grain. Now, first of all, you can take a quick look at this and go, hey, we're doing good. We're using 1/3 of the energy inputs of our conventional average neighbor. But the way we're looking at it, we're benchmarking ourselves. We're not really caring about what the industry average is. We just want to be getting better. We want to be improving that number, keeping in mind all the other factors that can be used to manipulate that number as well. So we live on a glacial moraine. It's a very rough land, but also very fragile. And it's really made us aware of the condition of the land. And we've been adopting the 5 soil health principles. I talked a little bit about this yesterday. And I just want to touch on a few of these. Today, right now, I want to talk about the reduced disturbance and how that plays into this. Dr. Helgeson this morning did a really good job explaining about the soil health, the aggregates, and how they're formed. I just want to reiterate, I'm going to be talking about soil fungi and how they produce glomalin. Glomalin produces aggregates. Aggregates increase your porosity, your soil infiltration capacity, your water holding capacity, and it increases your soil carbon. So to summarize that, fungi are good. Keep it going forward. That's the takeaway. So my wife Allison did the Elaine Ingham Life in the Soils course and has been evaluating our soils. And looking at the fungus to bacteria biomass ratios in our organic tilled soils are more bacterial. And as we reduce our tillage, we're getting more fungi. And as we add cover crops and as we adopt more of the soil health principles, we're seeing that improve. Now, we also, even though we're focused on improving our own farm, we do like to benchmark against our neighbors. And so Allison borrowed a few soil samples from some of our conventional neighbors. And by all accounts, they are good conventional neighbors. They're fairly high input, clean fields, high yielding, and they fell in right around our tilled land. So what we take away from that is that we've each removed a disturbance from our systems. We've removed the chemical disturbance, they have removed the physical disturbance, and we're at about the same level. And I'm sure if our conventional neighbors continued to reduce their chemical use, incorporate cover crops, they'd be moving along that scale just like we are. So one of our takeaways from this is we're on our farm, one of our goals is to reduce the intensity and the frequency of the tillage that we use. If we can use a less disruptive tillage machine, we'll reach for that before we go for something that's the high-speed disc, for example. Speaking of the high-speed disc, we did a side-by-side comparison between a roller crimper and a high-speed disc. We had a 90-acre field. We divided it into 8 plots. We roller crimped every other one, and we disked every other one like we traditionally had been doing our plow down acres. And one of the data points I pulled out of this is we measured fuel use. To do those 4 plots with the roller crimper 2 times, because that's what it took to get it nice and flat on the ground, it took 43 liters of fuel. We ran a Salford 5100, which is an independent opener disc, and it's a glorified plow. And we're traveling 8 miles an hour with a 540 horsepower tractor, and it was making that tractor snort pretty good. And that's 19 feet. Making a big tractor snort pretty good. Used 396 liters of fuel. So we had an 89% fuel reduction by going to the roller crimper, just straight up. We did soil testing. Okay, so this is the next spring now. It's overwintered, going into seeding. We worked the tilled fields twice with a cultivator, getting it ready for seeding. The stuff that we had crimped, we had variable results on the weed control. Some plots were good, some were not. So the 2 that were really not very good, we worked those once, and we called that the reduced tillage. And we soil tested each of them, and you can see the soil and how each of them, you can see Allison testing there. We've got the full tillage, the reduced tillage, and the non-tilled at all. And as you can imagine, as we reduce our tillage, the average length of the fungal strands increases. So those fungi are healthier, the hyphae are intact, and they're, well, a healthier fungi that's exuding more glomalin, building aggregates, building soil. And in the summer of 2018, we were dry again. And this is, believe it or not, that was supposed to be a spelt field. And it was dismal. It was a failure. But when I was taking pictures, I noticed there's this eroded knoll here. You can see a very distinct line between the no-till plot and the tilled plot. Now keep in mind, in 2018, this was all seeded the same day with the same drill from corner to corner. So there's no difference in the seeding. It's just the treatment before that. It's the tillage is the only difference. But whatever, I kind of forgot about it. This is a failed experiment. We were getting alfalfa coming back in. We're getting some perennials. So that fall, I pulled out the tandem disc and I'm working it in. And when I went over that knoll, I was really surprised to see the difference. All of this stuff about the fungi and building the carbon, building the soil, it sounds good in theory, but when you see this, that's showing you that we're building soil. This next picture I'm going to show you, it's this exact same spot, but I'm standing up here looking down slope. It's even more dramatic that you can see the color difference. This is from 1 year. We've changed this soil. We've moved in the right direction. From our soil testing that we did, we found that we increased the soil organic carbon in the no-till plots. Just a little bit, but we moved it in the right direction. The tilled plots, it actually went down by plowing in a sweet clover crop. And we're not talking very much, but we're moving the needle in the right direction. Also in the fall of 2018, the Organic Connections Conference was on in Saskatoon, and we were asked to bring some soil samples for the soil health demonstrations. We were asked to bring a sample of good soil and a sample of poor soil. Well, it was really easy. We just grabbed out of here for the poor soil. And I wasn't brave enough, I wish I was, to grab just a few feet away for an example of healthy soil. But this is going up in front of like 500 people and demonstrating our soils. I wasn't confident enough that we'd made that much of a change. That, like Dr. Helgeson talked about earlier, that this was probably more in the temporary organic carbon. It wasn't in the mineral associated carbon. So I took it from a known performer. We had a field that we'd spent 3 years in organic no-till. And when we put it in the slake test, there was just an amazing result. The tilled sample, it disintegrated into mud within 10 minutes. This picture was taken, okay, so what this is, if anybody isn't familiar with the slake test, you take a clod of dirt, you dry it, and you suspend it in water. The water rushes into the pores and it exerts a pressure inside the clump, inside that PED. And it tests the water soluble aggregate strength. So the stronger the aggregates, the better the soil, the more it's going to withstand. This picture was taken 6 hours after the clods were put into the water. So we've got a very strong soil in that 3-year no-till. And compared to the one that, well, I showed you off that knoll that just disintegrated in no time. So with these practices, we're showing that we're sequestering carbon, we're building soil. We are improving our aggregation, we're improving our infiltration, water holding capacity, and we're sequestering carbon, which, good or bad or not, that has been decided, that is the measure of goodness when it comes to climate change, that we're taking carbon from the atmosphere, we're putting it into the soil for the benefit of the environment, but also for the benefit of our soils and for our farm. With that, thank you very much. And we're doing questions now. Where's Stuart? Yep, we're doing questions now. Oop.
Questions from the floor. Producers, any questions right now?
Excellent presentation, thank you. Are you thinking about incorporating other forms of renewable energy like wind or geothermal, others?
When I was looking into things for the shop project, I looked into geothermal and I definitely decided to go more the solar thermal route. Running geothermal, you're basically running an air conditioner in reverse all winter. And it's, for the energy input all winter, the solar thermal made more sense. We were getting more heat per kilowatt of energy used. The geothermal would be more consistent. We probably wouldn't need a backup source, but we oversized our thermal panels a little bit by like 20%. So hopefully we can spend more months of the year without any backup this time of the year, if the system was up and running, I wouldn't be expecting to use a single bit of electricity this time of year. As for other energy sources, we've been playing with the idea of developing a biodiesel project, but that's, like I said, that's not off the ground by any means. That's still in the thought process.
Have you tried just doing any sort of mowing of green manures instead of in place of the roller crimper, like kind of do a similar idea?
Haven't tried any mowing. The idea is with the crimper, it keeps everything rooted and anchored to the ground. It's not going to blow away. It's not going to bunch. And our goal is to get to the point where we're growing enough biomass that once we lay that down, we're creating a mulch layer that's suppressing weeds and holding moisture, and we'll seed directly into that. And that's where we want the plants anchored in the soils, and they're not being pulled and pushed around by the next operation. Hence my presentation yesterday. We've gone from the roller crimper to cattle, so we've reduced some of that biomass with the cattle. So now we've got to produce even more if we want to create that mulch layer.
On your solar thermal heating system, what's your plan for the summer months when you've got heat to dissipate? Excess heat, that is.
When I talked to the supplier company, they said that I had to put in big heat exchangers, that we would be running the glycol through these radiators and blowing off all the heat all summer. I asked, well, why can't I just cover the panels? And there's just kind of silence on the other end of the phone that, you can't do that. I said, well, why not? If the sun's not hitting the panels and not heating up, we don't have to get rid of the heat. Well, I suppose that would work. So the plan is, I bought some simple, like, big haystack tarps. Alison promised me that she'll get a heavy duty stitcher, like a bag stitcher, and make up covers for these panels. That's the plan, is just cover them up. If anybody sees a problem with that, let me know, because I haven't seen the problem with it yet.
I had a quick question for you. So on your fuel calculation system, you're not pulling that data from the actual tractor units. You're just going in and recording, start of the field, 350 gallons in the tractor, and at the end, is that what you're doing? Just how the functionality of that data gathering at a time when we're all so busy at seeding and harvest and everything else. How's that going?
Yeah, one of the good side benefits of we share equipment with my parents on their farm, and the deal is everybody's paying for their own input. So when the tractor comes onto our field, it's full. When it leaves our land, it's full. So I just record that worked fields 1, 2, 3 with this implement, with this tractor, this seeder, and work this with knowing the number of fields or what fields it was. I can figure out the acres and added this number of liters of fuel to it, so I can work that backwards. And where it came to operators, I had with the combines. So it's when it comes to combines, I've got the even though they're identical combines, I do have the two identified as which is which to be able to pull that out.
Okay.
Yeah, my question was the same with the fuel, and you kind of explained some of it there. But another thing, I was wondering if you checked if you have used different fuel suppliers, but because I know myself personally, I've done that, and different fuel suppliers have, like, it's huge differences in efficiency in the diesel fuel itself. I've noticed that.
No, we haven't tried different suppliers. It's all been the same supplier.
Yeah.
That's interesting to know.
Yeah.
And all specifically diesel or gas or?
No, diesel in tractors.
Okay.
Like, I'm not knocking a co-op or anyone else, but it's I've run co-op diesel fuel in a specific tractor doing a specific job for this many years, and it's always been this much fuel that I've used. Switched to Nutrien, which is an SO product now, and it is noticeably less fuel that is being burned. So it works for me now because I'm using the same tractor with the same fuel, doing the same work. Whereas like for you now, it's your dad's using it, your brother's using it. That's all different. So that becomes hard to track a different fuel. But I've noticed it myself. So if someone else wants to play with that and see if it works for them too.
Mm-hmm. That's interesting.
Just a quick question about your comment about biodiesel. Have you done any calculations on the amount of energy that it takes to produce the energy you get out of the biofuel? I was involved with the pilot project there, the Farm Energy Evaluation Project. And one of the facts that came to light is that it takes approximately 13 calories of energy to put 1 calorie of energy on a dinner plate. And that, to turn it into a fuel, there's some more processes involved than simply what we do, put food on the plate. And it really starts to be a valuable calculation to make, where are you really gaining anything by growing your own fuel? And there was quite a push a number of years ago, biofuels and ethanol and things like that. And when you put that fact into the calculations, you wonder about the efficiency of doing that. The other thing that I noticed when we were doing farm evaluations, we did our own evaluation. We evaluated all the farm energy uses in the farm process, and we put it on a pie graph. And one of the reasons why an organic farmer is quite a bit more energy efficient than a conventional one, you would wonder why that is, because we do more tillage and things like that, which burns more diesel fuel. But diesel fuel isn't the big factor. When we used fertilizer, then the energy use went right through the roof. And I found that really interesting, because we often think about when we're growing plow down crop, for example, we think we're not having a crop that year, but we should consider that to be a crop, because there is a value in the nitrogen that we're putting into the soil, as well as all of the other advantages in building soil. But it is a product that normally would cost us X number of dollars that we are putting in, and the efficiency is good because it's already applied in the soil we're going to use it. There's no transportation or application costs. And so that's one of the thoughts that we have to put into when we're thinking about plow down or cover crops.
Your earlier comment about evaluating the biodiesel. No, I haven't crunched the numbers down fine on that, but I've spent some just kind of thought exercises on it. And we've got two kind of approaches that will help mitigate some of that energy use. That first off, the theory, and this isn't a plan, this is barely an idea, it's just kind of a theory at this point, is to intercrop some oil seeds with other crops, and hopefully at a low enough point that we're not hurting the value of our regular cash crop, but our companion will be providing just enough oil seed that we can get hopefully enough that we can crush and make biodiesel out of. From the process itself, yeah, there are some inputs like methanol that have to come from off farm and is again fairly energy intense. I know there's a process we could make our own ethanol and replace the methanol with ethanol, but that's very tricky. I'm not going to start there by any means. But one of the big energy inputs is heat, getting that oil heated up for the process. And all summer, we're going to have solar panels covered over. We can just uncover a couple solar panels, route the glycol loops through the oil tank, and heat the oil up for the process. So I don't know, like I said, I haven't crunched the numbers. This is all just kind of a thought exercise at this point. And I've not exactly comfortable talking about this here because it's still just a wild, crazy idea that we've been bouncing off the walls. So
Excellent. Thank you again for the presentation. It was a pleasure to have you come speak about some of the things you're doing on your farm.
well, thank you very much for inviting me.